Lesson 6-1, Graphing Systems of Equations. So systems of equations is when you are graphing a specific line compared to another line, and you're determining if it intersects, or if those two lines lie upon each other, or if they actually do not touch at all. So it's kind of a way to determine the system or the setup of the lines. So an ordered pair that is a solution of two equations is the solution of systems. So if you have an ordered pair that makes the systems or the equation true, then that means that it lies on the lines. So if an ordered pair makes both equations true, then the lines would intersect at that point. So a line or a system is consistent if it has at least one solution. So we say that a system is consistent if it has one solution. A system is independent if it has exactly one solution. So two lines intersect at exactly one point. It is dependent if it's a consistent system, but it has an infinite number of solutions. And it's an inconsistent system if there is no solutions. So the kind of lines that you may see for dependent would be two lines that lie upon each other, and inconsistent would be two lines that never touch each other. So here is just a visual way of looking at it. So for the first one, it has exactly one solution, so that makes it consistent and independent, but you can see that it meets at just one point. And then you have the next example, it's one line, so it's infinite, it's consistent, but it is dependent, meaning that there's technically two lines there or two equations that are true for all those points. And then the last example is no solution, meaning it's inconsistent, the lines never touch, so they run parallel to each other. So when we are using number of solutions, we may be given a graph like this one shown here. And it will say, use the graph at the right to determine whether each system is consistent or inconsistent, and if it is independent or dependent. So there you will be given some systems. So let's look at the system y equals negative 2x plus 3, which would be this line, so the green one, compared to y equals x minus 5, which is the maroon line. So here you can see that there's two lines, and the two lines intersect at one point. So they intersect right there. So we would call this system to be consistent, and it is going to be independent because they only meet at exactly one point, so each line is independent of each other. Now if we wanted to look at two different lines, we could look at y equals negative 2x minus 5, so the red line here, and compare that to y equals negative 2x plus 3, which is this green line up here. So you can see that these two lines are parallel to each other, which means that there is no solution because they don't intersect anywhere, they have nothing in common, and so these would be considered inconsistent. You can also determine the system of each graph by graphing each line and determining the relationship they have. So the first example, we're going to graph the first line of y equals negative 3x plus 10. So that means that my y-intercept is 10. So it's going to intersect about right here. And my slope is negative 3 over 1. So my line will look something like this. Doesn't have to be perfect. And then I'm going to graph the y equals x minus 2. So my y-intercept is negative 2, and my slope is 1 because there's a 1 in front of that x. So my line begins to look like this. Again, it doesn't have to be perfect. I'm just trying to sketch. And so we can see here that our line intersects, and it intersects at about this point, which is about 3, 1. So now you can check and see if that works for both of these equations. So for the first one, you can plug in your y, which is 1, and then for x, you have 3, and you want to see if it works, and it comes down to y equals 1, so that system works. And then you can plug it in for the other equation, and here again you get 1 equals 1, and so that one checks out. So you would know that your graph looks like this, and your solution is 3, 1. Pause the video to complete the lesson review. Make sure you show me this lesson review for verification of watching this video. I've also included that I want you to go to page 335 and look at example 3, read through the example, and read through the steps that are included. Make sure when you do your practice problems that you do number 9 on the practice problems. If you need help, feel free to ask.